this video, you're going to learn how to square a binomial. This is also known as finding a perfect square, because a perfect square is a square that has exactly identical side lengths. So when we multiply a binomial by itself, we're really essentially multiplying one side length by its identical side length over here to find the area in between. That's what our final trinomial really represents in terms of a 2D representation like this. So, squaring means to multiply a number or expression by itself, and in this case, when we square a binomial, it means that we are multiplying the binomial by itself. Here's an example of a binomial being squared. At this point, many people are under the misconception that you can just go ahead and write that this is 3x all squared plus 4 squared. So just taking the first term, squaring it, taking the second term and squaring it. But really, these two expressions are not identical. And the reason for this is that when we do expand that binomial, it really looks something like this, which means yes, we do multiply 3x by itself, just as we did up here, but we also have to multiply 3x by 4. And we need to multiply 4 by 3x, and then we do have that 4 squared on the end. So actually we need to do 4 sets of multiplication. So let's do them here. We've got 3x times 3x, which gives us 9x squared. We've got 3x times 4, which gives us positive 12x. We've got 4 lots of 3x, which gives us 12x. And we've got 4 times 4, which gives us 16. At this point, we have expanded the expression, but we haven't simplified it, because if you look here, you can see we've got two like terms, the 12x and the 12x. And they are like terms because they both end in just the pronumeral x, so they are like terms. If one ended in x and the other ended in xy, they wouldn't be like terms. Or if you look here, this one ends in x squared and this one ends in x. Again, those aren't like terms, so we can't put those two together, but we can put those two lots of 12x together. So we end up getting an expression that looks like this: 9x squared plus, now 12x plus 12x is 24x. And then we have 16 sitting on the end here. So this is what I would call the long way of finding out what the perfect square is. So the long way of expanding a binomial that's been squared. We're going to look at a quicker way of doing this. Let's take a closer look at what we've just done and see how we can use this to basically create a shortcut for ourselves. So you can see from what we have just spoken about back up here and comparing it to down here, that we do indeed have the first term in our answer as the first original term squared, and we have the last term in our answer as the last original term squared. Now what's happening in the middle here? We've got 24x, and this came from a 12x and a 12x. This 12x came from 3x times 4, and this 12x here came from 4 times 3x. See how these are the same calculations, 3x times 4 and 4 times 3x? And really what they are is the first original term times the second original term. And we end up doing that twice. So what we really end up with down here is multiplying the first term and the last term and then doubling that answer. You might see this in textbooks written like this. And that's just showing you that whatever your original binomial was, when you square it, you end up with the first term squared, at the end the last term squared, and in the middle we've got two lots of the first term times the last term, which is exactly what we had here, two lots of our first term times our last term. So let's use this shortcut and do some more examples. The very first term in our answer is going to be the first term squared, or the square of the first term. So we're going to take 3x and we are going to square that whole term. Alright, and we'll work out what that is in a second. Next we're going to multiply the first and last terms and double that. So the first term here is 3x, the last term here is 4, and we're also going to be doubling that. So we're going to write it like this: plus 2, that's our doubling, times the first term times the last term. And again, we're going to work that out in a moment. We're going to work out what we should write down here for the third term in our answer. The third term is going to be the square of the last term. So that is the square of this 4 up here. This is the last term in our original expression. So let's add on the last term and let's show that being squared. So what we need to do now is work out exactly what each of these 3 terms is going to be. So 3x all squared means we're going to do 3 squared, which is 9, and x squared, which is x squared. We're also going to do 2 times 3x times 4. So let's do 2 times 3 is 6, 6 times 4 is 24. And don't forget to pop that x pronumeral in there. And lastly, 4 squared. 4 squared is 16. So we pop that on the end, and you can see here we've achieved that same answer as before, but we've done it with this shortcut method. Now once you've practiced this line a few times, you can end up skipping straight from this bit here to your answer. But we're going to repeat this line a couple of times in our next couple of examples. But once you get to your working out, you can try it with that middle line in there, but then eventually you can eliminate that from your working out. This is example 2. So again, we're going to take the first term, which is 2x. We're going to square that whole first term. Then we're going to double the product of the first term and the last term. And then we're going to take the last term and we're going to square that. So 2x squared means 2 squared and x squared, plus 2 times 2 is 4, 4 times negative 5 is negative 20, and we have our pronumeral x, plus negative 5 squared. And remember, even if this is negative in here, it's going to become positive because 2 negatives when multiplied become positive. So 5 squared essentially is 25. And this is our answer, but we usually don't write it like this. We usually write it like this. So we leave the 4x squared alone. This just simply becomes minus. And that's our final answer. Now you could avoid originally writing down plus negative by going, okay, this is positive, this is positive, this is negative. So we've got one lot of negative in there. So when that's all multiplied, we're going to get a negative answer. So instead of putting this positive here, you could have just gone straight to writing that negative sign. All right, let's look at one more example. This one looks a little bit different because we've got pronumerals in the first term and we've got also a pronumeral in the second term. But you just follow the process identically to what we've done before. So we take the first term, square that whole first term, then double the product of the first term and the last term, and then take that last term and square that whole last term. And remember, we are taking any negatives that appear here and we are basically sticking them onto that last term and considering them to be part of that last term. So xy all squared means we're doing x squared and y squared. 2 times, now there's a coefficient in here of 1, times negative 3. So here, this tells us we need to have a subtraction sign. So we can go 2 times 1, which is 2, times 3, which is 6. X times x is x squared. And y, there's no second y, so we just are left with that one y here. plus negative 3x squared means we're doing negative 3 squared, which is positive 9, and x squared is x squared. And that's our answer. Now I just want to show you how you could have done this in your head. So it's fairly straightforward to think about the first term and square it. So think about it being xy times xy. And it's pretty straightforward to think about this last part of the answer here, which is the last term squared. So thinking about negative 3x times negative 3x. And to work out what this middle one's going to be, all you need to do is think about, well, what is xy times negative 3x? So that would be negative 3x squared y, and then double negative 3x squared y to get negative 6x squared y. So you can do that in your head, but equally valid to write this out. So whatever suits you and your learning. So now it's your turn to have a go with these 4 questions. What I'd like you to do is pause the video, have a go at these 4 questions, and then resume the video to check whether your answers are correct. If you run into any problems, please see my attached video to see the working out in full. So pause the video now and have a go. So I hope you've achieved some success with these questions. If you're unsure of anything, please send me an email or come and see me in class. Thanks for watching.